So in FDM, all users use the same common channel at the same time for full time, but they are only allowed different frequency to prevent any kind of signal interference. So the bandwidth is divided among the users, not time. There is possibility of crosstalk in FDM since all signals are transmitted simultaneously. But this crosstalk problem is not in the case of TDM, time deviant multiplexing. In time deviant multiplexing, the user are allotted their time slots in which they are allowed to transmit their signals, but they are given the full bandwidth for their time slot. After discussing FDM, we will now discuss TDM, that is time deviant multiplexing. Here again we will take the same example, so the concept becomes clear. Of 4 users and 4 users want to send their signal simultaneously on a common channel. So how can we use TDM so that there is no interference? Each user can transmit their signal over the common channel. Here again we have 4 users. This is the frequency band. Here in the vertical line we have the frequency band, and this is frequency band is available to all the users for the allotted time with full bandwidth. In FDM this was not the case. They were allotted certain bandwidth for their users. In this case, in TDM, time deviant multiplexing, user 1 use the full band, but the user 1 is allotted to use the channel for the duration of time, and then the time slot of user 2 starts. The user 2 use all bandwidth for its allowed time slot. The user 3, same case with the user 4. So in TDM there is no possibility of crosstalk. In TDM there is no crosstalk in TDM because each user has its allotted time, and in TDM the users are using the full bandwidth but for allotted time slot.